So hopefully you were able to watch the video of the guy ordering food. And that kind of leads us into this next topic that we'll be talking about. But going back to that situation where he's ordering food, let's say you wanted to order some food. Would you order like this if you wanted the following items? Would you ask for a cheeseburger, large fries, cheeseburger, hamburger, a Coke, and large fries? Hopefully, your answer is no, and that's because we can group like things together. So we can look at what we want. Well, there's a cheeseburger and another cheeseburger, so that means I want 2 cheeseburgers. Then there's large fries, another large fries, so I can group those together, and that's 2 large fries. The next item, there's a hamburger. There's nothing else I can group that with, so that means I only want 1 hamburger. And then there's only 1 Coke left. Okay, so this would be a more simpler way to order, a little bit more efficient, faster than just listing out every item because it can get confusing. So just like how we're able to group things when we're ordering, we can also group things in math when we're solving equations. And that's going to lead us into combining like terms. So we can combine or group like terms together. But first we need to talk about what are like terms. So like terms are going to be terms whose variables and their exponents are the same. So when we look at a term, we're just going to be focusing on the variable. If the variable is the same, so same letter and same exponent if it has an exponent, then they're going to be like terms. So it doesn't matter if the coefficient, so the number in front of the variable, is different. We just care about, is it the same variable? So let's take a look at an example. We've got 3 terms here, 1, 2, 3. So to determine if it's a like term, we look at the variable. Well, this has a variable of x, this has a variable of x, and this has a variable of x. So according to this definition, these are like terms. It doesn't matter that this has a coefficient of 7, this has a coefficient of 1, or this has a coefficient of -2. It doesn't matter. Remember, that just tells us how many we have. So it's like saying you have 7 hamburgers, 1 hamburger. We have -2 hamburgers, maybe you ate 2 hamburgers. So we could just group all the hamburgers together. So that's why we're focusing on just the variable. So this would be considered a set of like terms. Let's take a look at another example. 1/3 y to the 3rd power, -20 y to the 3rd, and y to the 3rd. Okay, so take a look at the variable. The variable this time is y, so that's good. So not only does the variable have to be the same, but if it has an exponent, like in this case it's raised to the 3rd power, then they all have to have that same exponent, which this is raised to the 3rd power, and this is raised to the 3rd power. So just looking at that, I know that these are like terms. I don't care about the coefficients at the moment. So these are like terms. Let's take a look at another example. 2x squared, 3x squared. All right, so this has a variable of x and it's raised to the 2nd power. This has no variable. This has a variable x and it's raised to the 2nd power. So if I'm just looking at all 3 and if I want to know if all 3 are like terms, then because of this 3, it doesn't share the same variable and exponent, these are not like terms. But I could say that 2x squared and 3x squared, just them two, are like terms. But if I'm looking at all 3 of them, then no, the 3 messes it up. All right, so the last example here are the following 3 like terms. So I have the number 5, -1/2, and -2. What do you think? Well, like terms, are terms whose variables and their exponents are the same. These don't have variables. Even though that they don't have variables, as long as they're all numbers, so these are all what we call constants, so 5, -1/2, -2, they're just numbers by themselves. numbers by themselves are also like terms as well. We could group those together. Like I could add 5 and a negative half together and negative 2. I'm able to combine just numbers together. Okay, so those are a few examples of what like terms are. So now that we know how to identify like terms, now let's combine them. So we can combine like terms if we see like terms if they're on the same side of the equation. So to combine, we just add the coefficients, and then whatever variable we have, it stays the same. So here's an example. Here we have the term 7x and 2x. So they both share the same variable x, and because they're like terms, I can now just look at the coefficients and add them together. So 7 plus 2 is 9, and then the variable stays the same. So it's kind of like saying you have 7 hamburgers and 2 hamburgers. Well, I'm going to be ordering 9 hamburgers. So that's why we can add them together. We're grouping them by adding. Let's try another one. Y plus 6y minus 2y. Okay, so these are like terms because here we have the same variable y. So I can group them by adding. So y by itself is just 1y. It's that invisible coefficient. So I've got 1y plus 6y plus a negative 2. So 1 plus 6 is 7 plus a negative 2 is 5. And then attach the variable. The variable stays the same. So it's kind of like saying now, let's say these are milkshakes. You have 1 milkshake, ordering 6 more. So now you ordered 7, but then you drink 2 of them. So now you're left with 5. So now let's take a look at when we have to combine like terms when we're solving an equation. So generally, you're going to see combining like terms grouped together with the distributive property. Generally, after you distribute, you're going to most likely have to combine like terms together. So let's take a look. I've got 3x plus 4 plus 4x equals negative 2. So I've got some parentheses here, so I know that I'm going to have to doing the distributive property. So you always, first step, just like in our last video, we always start with the distributive property first. So I'm going to take that 3, distribute it by multiplying to x. So 3 times x is 3x. Now I'm going to take that 3 and I'm going to multiply it by a positive 4. So 3 times 4 is a positive 12. And I'm going to drop down the right-hand side of the equation because I haven't touched that, plus 4x equals 2. And now I'm going to split my two sides of the equation so I can organize myself and know where to focus on. So after you distribute, always check both sides of your equation to see if there's anything that you can combine together. Okay, so looking at the left-hand side, I see that I have a 3x, and I've also got a positive 4x. Because they're on the same side of that equation, they're both sitting on the left-hand side, I can combine them by adding. So 3x's plus 4x's give me 7x's. Then that plus 12, there's nothing else on that left-hand side to combine it with, so I'm just going to drop it down. And then there's nothing on the right-hand side, so I'm just going to drop down equals negative 2. All right, so now I'm back to those two-step equations that we've been working on. So same steps here. You're going to identify your variable. So my variable is still on the left. I've got 7x. And this just helps me to focus on which side I'm going to work on. So I'm looking at the left-hand side. I'm trying to get that x by itself. But right now, I've got it being multiplied by 7 and adding 12. So I've got multiplication and addition. So always undo your addition or subtraction first on that same side of the variable. So I've got a plus 12, so I'm going to do the opposite, which is subtract 12. And I have to make sure to keep my equation balanced, so I have to do it to both sides. And then I can simplify. Plus 12 and a negative 12 zeros out. I'm going to drop down that 7x. Negative 2 plus a negative 12 is negative 14. And then after you undo your addition and subtraction, now you can undo any multiplication and division. Well, I have a 7x, so that implied operation is multiplication, 7 times x. So I can undo that by dividing by 7 on both sides. 7 divided by 7 goes to 1, so I'm left with just 1x that I can drop down. 1x and x are the same thing. And then negative 14 divided by 7 is a negative 2. So I was able to finally solve for x. It took a couple extra steps, but now I have my variable by itself. All right, one more example. So here we've got negative 2 times 3x minus 4 plus 5x plus 2 equals 12. So now the equations are starting to get bigger. So always, first step is distribute. So if you got any parentheses in your equation, clear the parentheses first. So I'm going to start with that outside number, negative 2, and I'm going to multiply by 3x. Negative 2 times 3x is negative 6x. Then negative 2 times negative 4. So don't forget that sign in front of the 4. It was a minus 4, so it's a negative 4. So negative 2 times negative 4 is a positive 8. Negative times a negative makes a positive. All right, I cleared that parentheses. Now I'm going to just drop everything else down because I haven't touched it yet. Separate your two sides. And after you distribute, always check, is there anything that I can combine together that's on the same side? And so I'm going to look at my left-hand side. There are things that I see are like terms. So first, I see a negative 6x, and I also see a positive 5x on that same side. So I can add them together. Negative 6 plus 5 is negative 1x. But I also see that I have constants on that same left-hand side. I've got a positive 8 and a positive 2. Well, I can group those together. A positive 8 and a positive 2 make a positive 10. So I cleaned up the left-hand side. Now it's cleaner. I only have two terms. On the right-hand side, there's just a 12 by itself, so there's nothing to combine. So I'm going to drop that down. All right, now I've got a two-step equation. I've got my variable. It's being multiplied by a negative 1. I'm adding 10 to it. And so I'm trying to get that x by itself. So I always have to first I have to identify the variable, which I talked about here. So I'm going to be focusing on that left-hand side. And then I always have to undo any addition or subtraction on that same side. So here on the left-hand side, I've got addition of 10. So I'm going to subtract 10. I'm going to do it to both sides. That positive 10 and a negative 10 goes to 0. So I'm going to drop down what's left, which is a negative 1x. And that's equal to 12 plus a negative 10, which is 2. So can we leave our answer like this? I have a 1x, but it's a negative x. Your x, when you solve your final answer, has to be positive. So I don't want a negative as my coefficient. So to undo that negative 1, I can, so right now it's negative 1 times x. So what I can do is undo that with division. I can divide by a negative 1. A negative 1 divided by a negative 1 is a positive 1x, which that's what I want. Positive 1x is the same thing as just x by itself. And then 2 divided by a negative 1 is a negative 2.